is going to be to end up with the same angle. Not difficult. Okay, well right now we've got a 5 pi over 12, and we got a minus pi over 12. Can we turn those things into the same angle? Well, the one thing you and I did not do last week is talk about odd even, did we?
No.
Well, let's talk about that, because we need that for these problems that have the negative angle. First of all, remember from your algebra that odd functions share this property. And even functions share this property. In other words, x squared is an even function. Y equal x is an odd function.
Yeah.
With trig, sine and tangent are odd, and cosine is even. And their reciprocals are the same thing they are. So cotangent is odd, cosecant is odd, and secant is even. So once again, just remember these three. You can always figure out the others. So immediately, I can write this as what?
As just secant of pi over 12.
Okay. And this other negative one, what's tangent of minus pi over 12?
Negative tangent over pi over 12.
Okay. So I got a lot of pi over 12s. I got 3 pi over 12s. Maybe we can turn this into a pi over 12. Now, we talked about cofunctions. Okay, and I said the sine of theta is equal to the cofunction of 90 degrees minus theta. Right?
Mm-hmm.
Well, when you're in radians, that's not 90 degrees. What is it?
That's pi over 2.
Okay. Now notice that if we took pi over 2 and we subtracted 5 pi over 12, we would have pi over 12, right?
Yeah.
So I can replace each of these with something that has the angle to be pi over 12.
Right.
So that's our first step. So let's turn everything into pi over 12. What does that become?
That's sine pi over 12.
Next one.
And then tangent pi over 12.
This is already secant pi over 12. This plus minus becomes a minus. Tangent pi over 12. And what's that? Already secant pi over 12. So first goal accomplished. I got the same angle.
You're missing cosecant over 12. Pi over 12.
Ah, you're right. I am. Oh, I bet I did that wrong in the previous problem. We'll find out when we get to the answer. I got it right now? Yeah. Okay.
Yeah.
Now, where we go once we got the angles are the same, unless you see something clearly obvious, probably the best thing is just convert everything to sines and cosines and see what you got. So, what is tangent?
Sine over cosine.
What is secant?
Cosine.
1 over.
1 over cosine. Yeah.
Tangent is sine over cosine. Secant is 1 over cosine. And cosecant is
That's just sine.
1 over.
1 over sine? Oh.
Well, it's the reciprocal.
Yeah.
In other words, it's never the same. Cosecant is never equal to sine. Well, only when it's at 1 is the answer. In other words, cosecant of 0 is the same as the sine. No, excuse me, that's not true either. Only when the sine is 1 is the cosecant also equal to 1, since the reciprocal of 1 is always 1. So now, what do we have on the left? We have sine squared over cosine squared. How can I write that?
It'd just be... What? It'd be sine or tangent squared.
Of pi over 12. I'll go ahead and add it back in. I left it out up here just because I didn't want to write it 6 times.
Yeah.
And this, that cancels with that, becomes 1 over cosine squared. How else can I write that?
It would be secant squared?
Yeah, it's a little bit like an irrational denominator. If you can write it as a numerator, do so. In other words, I would rather write secant squared than 1 over cosine squared. Don't leave your trig function in the denominator if you can turn it into the reciprocal. That's pretty much the rule. That's really funny because when I did this problem 30 minutes ago, I came up with tangent squared minus secant. And I said to my student, I suspect I have made a mathematical error because I'm expecting to come up with tangent squared minus secant squared. Why? Why was I expecting to come up with tangent squared minus secant squared?
To get a Pythagorean theorem, or
what is that equal
identity?
to? What is that equal to because of the Pythagorean identity?
Isn't it -1?
-1, exactly. And when I didn't come up with -1, I knew I had made a mistake. But I didn't want to take 20 minutes to go back from the problem from scratch and redo it. And now I see what happened. So I left one of these secants off. So I didn't end up with secant squared. I ended up with just secant. In other words, the last student didn't send it to me. She read it to me. And when I wrote down what she read, I left off one of these secants. So that's kind of funny. And I must have done the same thing on this problem, because on this problem here, I also did not come up with 1 or -1. All right, so when we first look at this, I see 1, 2, 3, 4, 5, 6 different angles. Every one of those angles is different. Okay? So, first of all, we have to we don't know yet which angle we're going to turn everything into. But let's start from the first term. What's the secant of 400 equal to?
Isn't it the secant of 40?
Yeah, the coterminal. Okay. Well, now I see a 40, and I see a 40 up here, and I see a bunch of 50s, which can be turned into 40s using cofunctions. So I'm beginning to think that 40 is going to be my final answer as to the angle that I'm going to use. Now, let's look at the cosine of 310.
Wouldn't it
What is
be...
that the equivalent of?
Wouldn't it just be cosine of 50?
Yes. So let's go with that. And then cosine of 50 is the equivalent of what if I'm trying to turn it into 40?
Sine of 40?
Now we're rolling. Now we know we're going to be able to turn all of these into a 40-degree angle. What's sine of 140 equal to?
Isn't it just sine of 50? Or what? Oh yeah.
There's the
Sine 40.
angle, 140.
Yeah.
It's in the second quadrant. So to figure out what its equivalent first quadrant is, I do this, 180 minus 140 to get 40 degrees.
Yeah, I just
Both
screwed up on my math.
They both are the same sine, so I can replace sine of 140 with sine of 40. What can I replace this with in order to change the angle to 40?
It can be, so it'd be sine of 50, so cosine of 40.
Hold on, we're talking this part right here, right?
Yeah.
Okay, I want to change the 50 to a 40. Do I want to use the cofunction? Do I want to use the reciprocal?
Cofunction.
What's the cofunction of cosecant?
Secant.
Okay, so that's what it is, secant of 40. And then the rest of it, well, first of all, let's turn that into a positive angle.
All right.
Is cotangent of minus 50, is it minus cotangent of 50 or is it plus cotangent of 50?
It would be minus cotangent of 50, so.
And finally, what's the tangent of 40?
It would just be negative tangent of 40.
Okay. Now, this is the only one I've got to replace with its what?
Just tangent 40. 1 over tangent 40.
No, you were right. Cofunctions are not reciprocal.
Oh, yeah.
We're using cofunction here. So I'm not going to replace it with 1 over that. I mean, I could replace it with 1 over tangent, but it would have to be 50. If I want to change it to 40, I got to replace it with tangent of 40. Okay. Now, this whole thing, there's 3 negative signs there. So that whole thing can be replaced by negative tan squared of 40. See that?
Yeah.
And what do you want to bet this is going to end up being? Some sort of a secant squared. Boy, it doesn't look like it though, does it?
No.
All right. In fact, what we have is secant squared of 40 sine squared of 40. Well, let's see. Secant is what? Relative to sine.
It would be...
Well, first of all, what's secant? What can we turn secant into?
Cosine.
1 over cosine.
Yeah, 1 over cosine.
In other words, here you have to use the reciprocal. We didn't change the angle. Okay, so that's the key. If you're changing the angle, it's usually you're using the cofunction. If you're changing the just the trig function, you're usually using the reciprocal. What's this equal to?
Tangent of...
Tangent squared 40. So what's our answer?
It'd be 0.
This is another one she didn't read right correctly to me, because when I did the problem with my previous students, she left off one of these terms over here also, which is easy to do. In fact, this is a great example. We didn't even get to number 3 because, well, maybe the fact that I just did them, I know how to do them faster. I don't know. Let's do number 3. So, it's not 100% clear which trig function I'm going to use, or which angle I'm going to end up with. Let's see if we can figure this out though. Is there a common angle here? In other words, if I wasn't looking at this or this, and I was just looking at this part here, what angle would I be trying to turn everything into?
30.
Yeah. Okay. Now, well, how does that relate to these two? It doesn't, but I'll show you what happens. Use the cofunction property on that. What do you get?
It would be sine of, it would be negative sinus 15. Yeah.
Now notice why I'm not trying to turn everything into 15, because what is that I just wrote?
It would just equal 1.
Negative 1. In other words, I got to factor out the negative 1 to leave sine, and it doesn't matter what that angle is, but sine squared plus cosine squared is always 1. So I can replace all of this with negative 1. And I happened to notice that when I was looking at it. And so I wasn't concerned with 15 degrees being the angle that I wanted to convert everything to, especially when I saw over here that there's kind of a common angle of 30. So what does this convert to?
It would just, wouldn't you look at the chart we have, like, it would just be 9, 30.
We may not need to. In other words, we may not need to come up with a number. We may end up with an identity that will just be equal to the number 1 or something. Notice that every problem you and I have done for the last 2 sessions did not matter what the angle was.
Yeah.
They all came up to either 1, negative 1, or 0, or some other number, regardless of the angle. So before we bother to figure out what those values are, let's see whether we need it or not. We're going to try to convert that to a 30 degree. So what do I have to write there in place of secant squared of 150?
It would be cosecant
Squared
of 1 of 30.
Okay, hold on. Let's back up a moment. I took one step and didn't talk about it. Secant is the reciprocal of what?
Of cosine.
So what's the equivalent first degree angle? 30.
It'd be, yeah, 30.
But if I write cosecant of 30, I got to change the sign. It becomes a minus. Well, let's do this step by step so I don't confuse you.
Okay.
First of all, I can't convert it using the 90 degrees minus theta.
Yeah.
Okay. First of all, I have to turn it into its equivalent first quadrant, which is secant squared of 30, but I got to change the sign because secant is negative in the second quadrant. So I can't just write secant squared of 30. That's not the same. But if I put a negative in front of it, it is. So I can say minus 9 secant squared of 30. You with me?
Yeah.
Minus 8 sine squared. If I want to put 30 in here, what do I have to do?
You have to make it a negative.
Yeah, change that negative to a positive, and now I can replace the 330 with 30, because that's fourth quadrant. So I can say the equivalent first quadrant angle is 30, but I got to change the sign on it.
All right.
Yeah, hold on a second. I may have made a mistake because it's being squared. that's the same as negative sine 30 times negative sine 30, which is the same as positive sine 30. So that stays negative. And the same rationale goes here. That was the same as negative secant 30, but then when I square it, it becomes positive, so it changes that to a positive. So now I'm there. I'm at that point right there. I like it so far because I see a 1, a plus 9, and a minus 8. Okay? So now I don't have any more identities. I can change that secant to 1 over cosine, but 1 over cosine minus sine isn't going to get me anywhere. So at this point, let's do this. Tell me if I lose you here. Now we can use our triangles and put some numbers in there. What's cosine of 30 equal to?
Isn't that root 3 over 2?
Yeah, so it's 9 over that squared, which is 3 over 4.
Yeah.
Okay. Minus 8. What's the sine of 30?
1/2.
So 1/2 squared.
1/2 squared.
Okay. Now let's simplify everything and see what we got. We got minus 1 plus 36 divided by 3, which is 12, minus 8 over 4, which is 2. So it looks like 9 is the answer.
All right.
And now the only thing that troubles me is that we needed not a calculator, but we needed to figure out. In other words, this is the first one we've done that hasn't come out, well, where the angle mattered. The fact that it was a 30-degree angle made a difference. Change that angle and you don't get 9 as an answer. Whereas every other problem did not matter whether you changed the angle or not. Yeah.
Yep.
See, and the instructions at the top are different on this than it was last week. Last week they said don't use a calculator or something.
Yeah.
Let's see. Do we have anything that?
No, I think I got this last one. I just took a picture of it. So it's just on the sheet. And then that last one's really easy.
Well, you know what the first step on this one is? On number 4, always draw a triangle and label theta or beta, whichever it is. Once you do that, then you can dimension 2 sides of that triangle, then you can dimension the third side, and then you can state what any trig function is. Because between this information and this information, you can figure out which quadrant you're in. This is a 4th quadrant, incidentally. I've done this problem. We did get to this problem. So that's 4th quadrant. Cosine of minus beta is the same as cosine of beta. So cosine is positive in the 4th. So this is a 4th quadrant problem. Just to let you know if you didn't come up with that assumption.
Yeah. But
the key on all of these problems is to draw the triangle, label theta. Draw a right triangle, label theta, and then dimension it. All right. Any other questions? In general, how's trig going for you? You doing okay in it?
Yeah, the trig stuff's easy. I just don't like my teacher at all.
Okay. Well,
she writes in cursive, and it's really difficult to read.
I'll bet. I mean, it's like a foreign language to begin with. And now she's writing a foreign language. That would be like teaching Spanish in cursive.
Yeah.
Nobody would do that, would they? I don't think anybody would do that.
Nope. Her cosine or cosecant and cosine
Oh
and her sine all look the same.
my gosh.
So
Wow.
you have to
That's a math teacher who's writing in cursive.
Yep.
Bet she wasn't trained as a math teacher.
I doubt it. None of my other teachers write in cursive.
No.
Even my English teacher.
Never heard of a math teacher writing in cursive because it's so important, let alone trig. But any kind of math should not be written in cursive. Trig in particular, because like you said, all the trig functions look similar.
Mm-hmm.
All right.
So,
Well, good luck with that. Trig is mainly about memory, so it's all about memorizing.
mm-hmm.
All right, Mitch. We'll talk to you next Tuesday, same time?
Yeah.
Okay, bye-bye.
Bye.